Good morning. So in today's video, I would like to review a little bit on ionic and covalent bonding. So basically, when we're looking at ionic bonding, what we have then is a metal bonding to a non-metal. And so that metal wants to give away its electron in order to get stable. So what it will do is it will lose an electron or 2 electrons or 3 electrons, and then basically will transfer that electron over to the nonmetal. And when it loses that negatively charged electron, it forms a positive ion. And so the number of protons is going to be greater than the number of electrons. And again, that's why it becomes a positive ion, okay? Now then, as far as that non-metal will take that electron. So it's going to gain an electron, a negatively charged electron. So it forms a negative ion because it's going to gain that electron. And so the number of protons over here is going to be less than the number of electrons. So those are going to have negative charges, okay? And another thing that those nonmetals can do is those nonmetals can also share their electrons with other nonmetals, and that's what a covalent bond is. Now, they're all trying to do the same thing. They're all trying to get stable, and the way that they get stable is to follow that octet rule. Remember that they all want to get 8 electrons in that outermost shell, so they follow that rule that allows them to then be more stable. And that's what those atoms, that's where those atoms want to be. And so we had talked about, an ionic bond is a metal bonded to a nonmetal. And the way that they do that is they will transfer an electron. And so we use an arrow to show that. And so that electron is transferred from one atom to another. And so transfer or, moving that over. But they're all trying to get to that full valence shell. And remember, that magic number is 8. And then a covalent bond is another way of doing that. So that would be a non-metal bonded to another non-metal. And the way that they do it is they actually will share electrons. I'm going to put my little electron there. And instead of using an arrow to show that, I'm going to put a circle around it, because they will want to then, instead of transferring, they share electrons. So they have shared electrons, but the goal is the same, to get that full valence shell. So it'll be 8 and stable, okay? So then let's go into maybe some more examples then of these ionic bonds. So when we look at these examples, the one that we use a lot is salt, so sodium chloride. So I find I'm going to first want to do the Lewis structures, or the electron dot diagrams of these. So first of all, sodium is going to have 1 dot, and my chlorine is in group 7, so it's going to have 7 dots here. And I'm going to use arrows to show the transfer of that electron. So before bonding, you can see those are my dots. Those are my electrons. Those dots represent electrons. And so I'm going to be moving that electron, or transferring that electron, over to the chlorine. And when that happens, that causes that sodium to have a positive charge, that chlorine to have a negative charge, and so it forms sodium chloride by transferring that electron. Okay, let's do another example. Lithium, group 1, has 1 dot. Bromine has 7 dots, 7 electrons. So again, I'm going to transfer that electron over. And so when I then, that lithium forms a positive ion, bromine negative ion, is my chemical formula. Okay, let's do a little bit harder. So I have magnesium here is in group 2, so I'm putting 2 dots there. My oxygen is in group 6, so it has 6 dots. And now I'm going to be transferring actually 2 electrons over. So I'm going to have the transfer of 2 electrons, so 1 there and 1 there. And so my ionic charges are going to be 2 plus for magnesium, and my oxygen is going to be 2 minus. But because that, ionic charge is, still going to need to be 0, I can see magnesium, I'm just going to need 1 of those for my oxygen on that. Okay. Okay, so let's look at some examples then of covalent bonding. And on covalent bonding, I'm going to use circles to show how those electrons are being shared. So hydrochloric acid, or HCl. Again, I start by putting my Lewis structures. So I put 1 dot by the hydrogen and 7 dots by the chlorine. But instead of using an arrow here, I'm going to use a circle to show how those are being shared. And then when I write out that structure, that circle forms a line that shows how that is being formed. And so this then would be HCl. Okay, let's do another example. On this example, I'm going to have hydrogen has 1 dot. My oxygen, remember, has 6 dots. And as I start drawing my circles here, what I'm going to notice is that I'm going to actually need another hydrogen, because I still have, this little electron down here that doesn't have a pair. Remember, they need to be in pairs. And so I'm going to go ahead and draw another hydrogen down here, and I'm going to use my circle to show how that's bonded. And so this is actually H2O. So that's going to be water, because I have my hydrogen here oxygen, and then another hydrogen there that is bonding that together. So I needed, in order to get that oxygen to 8, I needed to share two, electrons from 2 different hydrogens. Okay, let's go ahead and do one more example. On this one, again, I have my hydrogen with 1 dot, and my carbon is going to have 4 dots. So I'm going to start making my circles here to show the sharing of electrons in that covalent bond. But now you can see I actually have 3 sides of that carbon that still need to be bonded with something. So I'm going to draw some more hydrogens here. So I'll put one right there, and another hydrogen right there. And then I'm going to show those covalent bonds that are being formed between those nonmetals. And then I can go ahead and write my structure here. Because again, each of those circles becomes a line. And so then the chemical formula for that would be CH4, which is actually methane, would be the structure for that. Okay, so I hope this little review helps explain how ionic and covalent bonding work. The biggest thing to just keep in mind is that the goal of each of these is to reach a stable valence shell with 8 electrons. That's the whole goal. So thank you again. And as always, if you have any questions, please don't hesitate to let me know.